classes. So we have to survive that situation by becoming ourselves to be competitive. This is my suggestion. Now we are passing on to our last day's session. The 21st part is actually this is supposed to be the 24th part, but some parts we have mixed up. That is why this has become the 21st part. This is on green engineering. Let us see what is green engineering. The next slide will tell us what is green engineering. What is basically engineering? Engineering is the application of science and technology. Science is the theoretical part, technology is the application part, and when both these things are used for the betterment of the life of people, we say it is engineering. So engineering is the real-time activity which is going on for bettering the lifestyle of the people. So it may involve a lot of design, a lot of discovery and implementation. It may involve miniature deals at molecular level. It may involve products or processes, or it may involve a complicated group of things which is called a system. It may involve in maximizing the inherency. Inherency means the inborn things which we traditionally acquire, the knowledge which is traditionally acquired, which would have been handed over to us by the past generations. And it may involve in maximizing the mass, energy, time, and space efficiency. Please keep in mind it's only increasing the efficiency. Efficiency doesn't mean we can increase mass or energy. Only efficiency we can increase. Take, for example, in this room which I'm sitting, when I started using this room, I put a 36-watt LED bulb. A 36-watt LED bulb is giving my light equivalent to around 150-watt incandescent bulb. So I think you can all see my face very clearly because I'm using that LED bulb, very powerful LED bulb. So this is a new development. Maybe 2 years back, I couldn't think of this LED bulb. This is what is nowadays called the T bulb. It works as T bulb doesn't have shadow. That is its advantage. Whereas a single point bulb may have shadow. A T bulb in LED will not have shadow. So I can use it for presentation. And this I cannot think of 2 years back. So things have changed. So this is a concept of green engineering. This LED bulb which I am using is a product of the design and discovery of green engineering. This is what is to be kept in mind. So these are all what is comprising what is green engineering. So in a nutshell, I can say green engineering is the total or the totality of everything we have discussed so far. If it is utilized for bettering the lives of human beings, we can say it is green engineering. So it can involve design. Say I'm a civil engineer by profession. So a green engineering in civil engineering means a green design for the structure, green materials for the structure, green construction of the structure, green utilization of the structure, and green performance of the structure. Or it simply means a design that will reduce the materials and improve the efficiency, and a utility at the end of it which uses less power and energy. All this together we call as green engineering. See the next slide. Why do we need green engineering? Because green engineering do have definitely some goals are there. What we want to achieve, we want our engineering to be applicable. That means usable. Suppose in these days you are coming up with again the incandescent bulb which Thomas Alva Edison made. People will laugh at you because the operational cost is very high for a bulb compared to its lifetime cost. An incandescent bulb may cost only 10 rupees, but in its life, it may be using hundreds of rupees of power. So application is very important. And you need it to be effective because to be effective means it should serve the purpose effectively. Then incandescent bulb, more than 90% of the energy is used for heating. Whereas in an LED light, more than 90% of the energy is used for lighting. So the effectiveness is just reverse. Similarly, it should be appropriate. Appropriate means we have a new branch of technology called appropriate technology. So appropriate technology means using the right thing at the right place at the right time. That is called appropriate technology. If your technology cannot use that, you cannot say it is appropriate technology. Now you know that air conditioner, say, I told that it is very hot here now. I had to switch on the air conditioner. But I've kept a temperature of only 25 degree. Why? Because when the ambient temperature becomes 25 degree, that AC will shut off by itself. I'm saving the energy. So,
voice ഇടയ്ക്കൊരു break ഉണ്ട്.
pardon, noise disturbance is there. Hello.
Now okay, sir. ഇടയ്ക്കൊരു break ഉണ്ടായിരുന്നു.
That is because unknowingly I move on the chair. Unluckily, I have put a rolling chair.
Okay.
I'll take care.
Now
While talking unknowingly, I just swab around. That may be the reason. I'll take care. Okay. Then a green engineering should be applicable across disciplines. So a green engineering concept which you have developed in electrical engineering should be able to be applied in, say, electronics engineering or computer science and engineering, or anywhere you want, or mechanical engineering. It should be applicable everywhere. That is another concept of green engineering. Say energy saving. Energy saving in air conditioner is an electrical principle. But air conditioner is not made by electrical engineers only. It's also made by mechanical engineers, where the mechanisms inside are designed by the mechanical engineers. So it is equally, it should be applicable to mechanical engineers. Then apply across scales of design. That means a concept which you apply to a miniature thing, say a concept which you apply to a small bulb, should be applicable to even a huge generator which produces energy. That means energy saving concept have to be applied in magnified scales wherever possible. A small bulb of 9 watts which you use in LED bulb for a room should be applicable even to a stadium lighting by flood lighting. There, instead of putting 5,000 or 2,000 watt bulbs, you should be able to put a 100 or 200 watt bulb to serve the purpose. So the scale of utility should be there. That is another thing. Then another thing is, let us see the next slide. How we are going to apply the principles of green engineering and how it is developed. Again, I told that sometime back, I told you we have to learn from nature everything. I quoted the example of Burj Khalifa Tower, which has simulated the shape of a flower, Hymenocallis. So similarly, nature is the best teacher. The first person who wanted to make some fluorescent things studied the ephemera. Ephemera means, the in Malayalam we call minna minima, which has got some chemicals in it and which become fluorescent. So that is how we got the concept of fluorescence. So man who made the fluorescent bulb studied what is the compound in nature which makes fluorescence. Similarly, in nature there are underlying principles for everything. The first we identify that, say when you go for submarine, you go for the design shape of a shark. The shark is always underwater. But when you go for a boat, you may go for the shape of a fish which swims on top of water. Both shapes will be different. That is why the shape of an underwater submarine is entirely different from the shape of a boat which is floating over the water. It has to be different. So nature's principle, we have to see the underlying principle which are embedded there. And also, we also have to see that these principles are across scales. Something which is applicable to a model will be applicable to even a prototype. That is also there. So these are the basic principles of green engineering. Still more are there. We'll see that. And of course, see the next slide, we'll see some more examples. Things need not go exactly by rules or revelations or commandments. Should go by performance parameters. Say a rule may say that a kite will swing in the atmosphere very effectively. But can we make an aeroplane in the shape of a kite? Not possible, because the kite has got a flexible tail. But an aeroplane moving high up in the air cannot have a flexible tail. But the same principle we can apply to helicopter, which flies only just above the ground level. We can have the kite principle, because that will have a heavy atmospheric or a air pressure which can work. So we have to go by practical or performance evaluation, not based exactly on the concept or theory. More practically oriented we have to be. And one more thing is we have to be more application oriented. That is where innovation and creativity do come. Instead of going by a rotten principles, when we go by a realistic thing. I quote one example. There was an architect in Kerala who was very famous, Laurie Baker. The government of Kerala was having a Laurie Baker International School of Habitat Studies, and I was its dean for a long time. Why the government of Kerala respected Laurie Baker is he was a British architect. He came to Kerala because his wife was from Kerala. He settled in Kerala and he found what are the culture, what are the practices, and what are the materials available in Kerala. And he devised a new architecture, a cost-effective architecture for Kerala, not based on the British principles, but based on the local materials, the local tradition, and the local workers. So he made a Becker model construction in Kerala, which dominated Kerala for 3 to 4 decades. Even now, it is very prominent. Organizations like Postfort, Nirmadi Kendra are following Becker model construction. And of course, at Tiruvandhuram, there is a well-known architect. He is the only living architect in Kerala with the Padma Shri awarded to him. He is a good friend of mine, Mr. Shankar. He is also propagating this principle, the Becker model construction. And of course, in the initial stages when Shankar was starting his practice as an architect, he was with Becker for a long period, and he has inherited some of the concepts of Becker. So what I'm saying is that this is need-based, location-based, utility-based concept. So in construction engineering, we always say Becker model was a green engineering model because he used mostly waste materials. At that time, so much of tiles were available in Kerala as a waste material. He used the tiles for construction. At that time, burned bricks were available in Kerala. He used that as the base block material. He knew that cement is a red material, which is against nature, but lime is a green material. So he promoted the use of lime. Like that, so many green concepts in construction engineering. Yes, of course, I'm not going into more details because Becker has been our role model when we started cost-effective construction techniques. And that is one of the best examples of green engineering. Now let us see the next slide. So any green engineering principle should synergize with the traditional design metrics. Traditional design metrics have been always, what do you mean by metrics? Metrics basically mean measurement. But it's not simply measurement, it is measurement, proportioning, compatibility, all this comes in what is called metrics. So if some new activity you are doing is synergizing means joining with or compromising with or agreeing with quality, safety, and cost-effective characters of the tradition. Tradition always used to have so many such concepts. You must be knowing that 150 years back, all the houses in Kerala were dependent on coconut trees. And Kerala was full of coconut trees. All the columns in the houses were coconut timber. Very rarely they used other timbers. Teakwood was not here at that time. Teakwood came later. Teakwood was brought by Westerners. They relied more on teakwood. But coconut was very common here. Coconut was used for the columns. Coconut was used for the roof. And coconut leaves were used for the roof sheeting, thatching. So coconut was, and even the palace of the Travancore king was coconut leaf called. It was called by, cladding was entirely by coconut leaf. I have seen that photograph somewhere. 1.5 century back, the Travancore palace at Kavadiyar was thatched with coconut leaf. There was no tile, there were no concrete. Now it would have all changed. Tiles came to Kerala around 120, 130 years back. Before that, it was a traditional construction technique which was fully green technology because all these materials and the flooring was made with mud, with the processed mud and cow dung, finished was the flooring. So all these materials were very much green materials. After the utility period, they used to dissolve to the nature. So no harm to the nature. So Quality was also good, not bad. Only thing was their longevity. Say the thatching by coconut leaf may last for 2 years, at the most last for 3 years. So we had to renew it. Okay. So all this had a concept of what is called moving to sustainability. So I think the future we will go back to this concept. Now people are getting aware. Maybe after 1 century, we may go back to the concept which we have been using 1.5 centuries back. Quite possible because we are now understanding that infiltrating onto the right of the nature. We have our own right, nature has its own right. So we may go back to, and this COVID period has given us a lesson. All over the world, it is reported that in the COVID period, the humanity has gone 20 to 30 years back. Maybe except in electronics or computer software, all other aspects. In consumption also, we have gone 20 to 30 years back. See, we can go back. That is what Gandhiji has said. We have to go back to the civilization. So then only the nature will have its own free entity. Now see the next slide. So I told we should have some inherency, things which have been practiced in the past. If it is good, we should practice in the future also. In the 70s and 80s and 90s, we had a custom of throwing away everything the old people used. We used to blame that these are all old things. The civilization has changed. Even old people were also despised. That you will understand their value only when you become old. Otherwise, you never understand the value of old people. They have got a lot of experience which counts. Maybe technology-wise, science-wise, they may not match with the young people. But experience-wise, and remember, for the life on this earth, experience is most valuable than science and technology. Science and technology can survive up to an extent, and beyond that, only experience can survive. That is why the knowledge of the land, the inherited values, inherited customs, these were all important, and we should accumulate them in such a way that we have what is called a holistic system. In medicine, we always use this term, holistic medicine. That means Ayurveda, modern medicine, allopathy, all this combined and giving an integrated treatment is what is called holistic medicine. And a holistic system is always good. You know that in modern medicine, there is no treatment for many diseases. In Ayurveda, actually, Ayurveda doesn't have any medicine. Ayurveda is for swasthya, means health. It is not for disease. The modern Ayurveda practitioners are interpreting it as medicines. In Ayurveda, actually, Ayurveda is an Upaveda. Ayurveda is an Upaveda of the four Vedas. There are four Vedas and four Upavedas, and Ayurveda is an Upaveda which is thousands of years old. And Ayurveda is a science of health, not the science of medicine. Ayur means life, Veda means knowledge. So the knowledge of life, that is Ayurveda. It doesn't have any medicine as is prescribed, but whatever is prescribed in Ayurveda, people are using as medicine. That is why people say Ayurveda is failing. Ayurveda never fails because Ayurveda never propounded medicine. It propounded only practice which you have to do for your health. And of course, some food restrictions are there that also you have to do. And some natural food items are there we have to take, which we nowadays call Ayurveda medicines, which those days they used to call Ayurveda prescriptions, not medicines. Okay. Now, that is what is called a holistic system. Even today, it is very required because, which is the best medicine against pathogens in the world? I used to ask this question to many people, which is the best curative measure for pathogens? Pathogens means disease-causing organisms, bacteria, virus, etc., etc. And that is abundantly available in nature. That in Sanskrit is called prana vayu, the vayu, the gas of life, that is oxygen. Oxygen kills almost all living, all pathogens, disease-causing organisms. That is why these disease-causing organisms do survive where oxygen is absent. And when the oxygen is absent, we say it is septic condition. And in our body, if oxygen is absent in some part of the body, we call it as septicus, and that part will become blue and we may gradually become dead because of the septicus. So septic condition is the condition where pathogens grow. So your room which you are sitting, your vehicle which you are traveling, Say, for example, you are moving by a car, an air-conditioned car. I always suggest that half an hour to 1 hour, you should sometime let in fresh air inside because otherwise septic condition will develop inside your car. If you are going on a long journey and you are using a closed car with air conditioner, after 1 or 2 hours of travel, you will become dizzy because the oxygen supply in your car will go down and your hemoglobin will be able to absorb less and less oxygen. And when the oxygen supply inside your car is very poor, you become dizzy and you feel like sleeping. So wherever you go by car for a long trip, if your car is closed with an air conditioner, either open the valve of the air conditioner. Air conditioner has got a valve which will let in fresh air even without opening the glass. But the thing is that gas is coming through the engine side, so it may have dust or impure things in it. But if you can let open the side glass for 1 or 2 minutes, abundant fresh air will come and that will cleanse everything inside. So keep this a habit from your health point of view. Whenever, moreover, if you are using an air conditioned room, don't close the room and use air conditioner. Some opening you can give in the room. Some opening in the sense the air should escape and fresh air should come. Or there is nothing wrong even if a small window is open because some power you have to spend extra, but you will have fresh air because air conditioner, especially split air conditioner, doesn't bring any fresh air to the room. It recirculates the used air inside the room, so carbon dioxide intensity will be very high. So nowadays people use only split air conditioner. They don't go for window air conditioner. Window air conditioner used to have a system by which fresh air enters, but split air conditioner doesn't have such a system. It only recirculates the air inside. So if only there are some small. Normally, what I do is if I am using air conditioner, I keep open a small window. Let some power go, but after some cooling off, you can switch off the air conditioner because that will give you a better, synergized system for survival and where pathogens will not grow. Let us see the next slide. So this is just a graph which shows how we can redefine the concepts of green engineering. If you optimize the existing solution, that bottom white part is what the outcome will be. What will be the performance level? But if you can re-engineer the system, re-engineer system means I'll explain this with respect to a building. Suppose there is an old building, insufficient windows are there, tiled roof is there, and the floor is very ugly. So you re-engineer the system. You put a better flooring. You put some 2, 3 good windows for ventilation and air conditioning, and then ultimately you redefine the problem. That means you have got very good, and suppose there are some rooms where air circulation is not proper, fit some fan or AC there so that once in a while you can cool it if you want. So you are redefining the problem. And of course, when I'm saying air conditioner, people will feel that that is against a green concept. No, air conditioner is always not a red concept if it is used properly. So that is what I say when you use the air conditioner, keep the temperature between 24 and 26 degrees centigrade because at that temperature level, your AC will need only 1/4 of the energy which it would have consumed if the temperature was very low. So even AC can be used in a green system only when it is very necessary. But as I told, fresh air is always the better choice. See the next slide. There are 12 principles in green engineering. They are concerning the design, the manufacture, the erection or implementation, and the utilization. Let us see what are these 12 principles. And when you become an engineer for a project or something, keep in mind that you are using these 12 principles. The first principle is designers should ensure that material and energy inputs are the least and outputs are non-hazardous. Inputs are less and outputs are non-hazardous. What do you mean by inputs are less? Less material we should have. Like I told the case of Baker, he always used very less materials and if possible, waste materials. Then output should be non-hazardous. What do you mean by non-hazardous outputs? Non-hazardous output means, I'm sorry, some heavy vehicle is moving by the side. The sound is interfering. Somebody is moving nearby. Okay. So, non-hazardous output means if the working system, if the working system of an equipment or a machinery is giving out hazardous outputs, then it is not advisable. That is what we have to keep in mind. So we should always say you are using a kiln or a stove, and you feel that the outcome from the stove is going to be pampering the system inside the house, then that is not a green principle. You would have seen, again I am coming back to Baker. Baker used to make small chimneys in households. The chimneys were designed in simple systems such that all the gaseous output coming out of that system used to escape from the house, didn't stay back in the house. So that was a non-hazardous exhaust system for the building. This is one principle. See the next principle. The civilizations in general have a system. They make waste and throw it away. But why should we make waste? A simple case, you know that there are only two people at your home. So you cook only for two people, waste will not be there. But if you cook some extra, there will be waste. So it is better to prevent the waste than to treat it or cleaning it up. This is the second principle. So when designing anything, whether it is a house or whether it is a machine, always keep in mind that you are designing with the minimum required material. That I have once mentioned. What is that concept called? That concept is what is called frugal design, designing with the minimum waste, designing with the minimum material. That should be the, whether you are a civil engineer or a chemical engineer or an electronic engineer, when you design something, always ensure that you waste the minimum, you utilize the maximum. Okay. See the next principle. Okay, this is an example for the principle. Second principle I have told. You can have containment systems for storage and disposal so that anything, say, this principle also implies a fridge in a house. Why we need a fridge in a house? Because suppose you cook something extra, you can refrigerate it and keep it so that it becomes your food for the next day. People do say that refrigerated food is bad, refrigerated food is unhealthy. That is an old concept. I don't see any change in refrigerated food because almost all of the advanced nation, they are using only refrigerated food. So maybe from the old people's point of view, refrigeration may be a fashion, but it's a necessity in many of the houses. Suppose you want to cook every day, and the women are also employed, means cooking every day is impossible. So refrigeration, don't think that refrigerated food are very bad, but remember one thing: if you keep rotten food in refrigerator, you cannot prevent it getting rotten further. So whenever you keep something in refrigerator, you have to ensure that you are keeping fresh food, not rotten food. That is the only thing to be. So containing such systems for containing the leftover, for containing, say, waste is coming in a steel industry, that can be kept in a container and that can be used for making further steel. That is possible. Okay. So these are all things which we can use in this principle, avoiding the wastage. Come to the next slide. Separation and purification should be a component of the design. Because if separation and purification are a component of the design, waste effort, say you are purifying and separating at one place and you are taking that material to another place, again it has to be purified for the process. So it is better that always the purification process and the separation process are combined with the production process. The advantage is unwanted transportation. Take for example, you are cleaning the plates in your kitchen and keeping it in some other area. So every time you bring that plate to kitchen back, you have to clean it again because you don't know what has happened there. So that system can be avoided if you are using the day-to-day vessels in the kitchen itself. Immediately on cleaning, you can use it for your purposes. One simple example. Now let us see the next one. An extension of the principle 3. Upfront design allows, okay, upfront design allows products to self-separate using intrinsic physical chemical properties such as solubility, volatility, etc. So this is one principle where separation I'll tell you a very simple example. Earlier days, we used to have, the crystal salt or called the rock salt. Now, that time, the powder salt was not available. Nowadays, we get the powder salt, which is double purified and packed. Those time, only crystal salt, which are collected directly from the hills or from the Uppala in the seacoast area, were available. So we all used to have a system where there was a vessel in every house in the kitchen where this rock salt will be put and water will be put over it. Water will be filled in the vessel. So this water will be heavily salt water. Every time you take 1 or 2 teaspoonful of this water, and that is used as salt water. So there was an embedded cleaning system in it. This rock salt may have many minerals, but out of that minerals, only the soluble minerals, which are chlorides, will get into this water. And this water, we take it and we just pour it, and we always will have a small, filter mechanism by a cloth through which we pour this salt water to the curry which we want, not like powder these days. So that was a purified form, and an embedded system was there by which that purification was take place. So that was a non-costly system. If you wanted to go for purifying the rock salt, it would have been very costly because salt was pretty cheap at that time. Nowadays, it's not. Powdered and purified salt are very costly because at that time the salt was a necessity for the poor man, and the government insisted that salt should be available in cheap cost in the rock salt form. Even now, that insistence is there in many states, but still the costly ones are also available. So it is an extension of the design principle 3 that intrinsic physical chemical properties such as solubility, volatility, etc., can be kept and can be used for reducing the cost of production of that material. So the cost of production of pure salt at that time was very cheap compared to the cost of production of pure salt now, which is in purified distilled form. Okay, see the next slide. Whenever you design a system, whether it's a mechanical system or electrical system or an electronic circuit, keep in mind that it can give the maximum output in the form of mass or energy, and it can give the maximum temporal efficiency. Temporal means for required time, it is called temporal, time dependent. For temporal efficiency should be higher. Say you are using an electronic circuit for one particular purpose, you should ensure that at the time when the circuit is being used, its efficiency is the highest, its output is the highest, or the signal is the highest. This is the fourth principle. So we have to design it accordingly. In other times when it is not being used, there is no need for any of these things. Only when it is being used, this efficiency has to be there. That is why now, most of the mobiles do have a system, sleep system. You can set the mobile to a sleep system. Even the computers do have the sleep system. You can set the sleep time, say 1 minute. That means 1 minute after you stop the use, it will sleep by itself. That means 99% of the energy will be saved. You don't have to. Earlier, this system was not there for computers as well as for laptop. This system was not there earlier, but later it came. So now you don't have to worry about it. You just leave the system, and I have seen that my children never even switch off the system. They use the system, they go away, they come back and again work on the system, and the power will be remaining still there because the system has got its own set sleeping properties, which is meant to improve the efficiency of the system. So if a laptop is not having that system, you just think after 3 hours the entire power will be drained off. But now nothing will happen. You would have given this time for 1 minute or 5 minutes, whatever it is. After that, the system will sleep by itself, and the power will still remain there. That is an efficiency improving system. That concept you should have everywhere. Take for example, you are having a house. You are making a house. You ensure that in the cold season, that house will give you higher temperature, and in the hot season, that house will give you less temperature. This also I got from Baker. I have gone to the house where he lived first time. When he came to Kerala, he lived at a place called Wagaman. It's in, I think, in Kottayam district, Kottayam or Idukki, whatever it is. I have gone to Wagaman twice or thrice because this house which Baker stayed there was owned by one of my good friend Ajit. Ajit was my publisher at Bombay. So Ajit has purchased his house, and I used to visit that house quite frequently. And whenever I get into that house, I felt that if it is hot season, inside that house was very cool. And if it is cool season, Vagamon is a very cold place also. If it is cool season, inside that house, the temperature was very high. So I used to Ajit how this happened. So he said it is Berkeley's miracle. He has given some openings here and there, some particular cardinal points such that in the hot season, the room will become cool, and in the cold season, the room will become hot. And that room was not at all air conditioned. That Baker and his wife stayed there for years and years till they shifted out to Trivandrum. See, this is one principle where we can use the temporal efficiency of the building. Now come to the next principle. This is, of course, an electronic example of it. Now come to fifth principle. The system components should be, please click once more. You will see the Le-Chatelier principle there. This, okay, that is it. This I told is a Le-Chatelier principle, which you have studied in chemistry in school days. The Le-Chatelier principle, it says that if a system is in equilibrium, a system in equilibrium is subjected to a stress. The equilibrium will shift in the direction which tends to relieve that stress. I think this is also a human reality also. A human reality in the sense, suppose you are under so much of stress. Those who have studied medical science or psychology will be knowing it. If you are under too much of stress, your body will secrete some hormones which will dilute the stress. It's a natural process. The same thing happens in a chemical system or physical system. When the system goes to inequilibrium, especially under external pressure, the system will try to stabilize itself by some internal adjustment. So, whatever system we design, it should be such that this principle is followed. Say, I have told that suppose there is heavy pressure outside in a submarine. If it goes very deep, sometimes the depth of the sea may be very high. And I also has mentioned that there are some locations in the sea where depth is over even 15 kilometers, twice the height of Everest. So if something happens like that, the submarine should have a system by which it can control its internal pressures. Okay, so that is one thing which you have to keep in mind. Whenever something goes out of our control, this is especially very important in space travel. I don't know whether you attended that session which I conducted on you and the universe, where I discussed about the space travel. And whenever the space travel is there will be so many things which go unexpected. And we should have a system by which, say, in our body, I'll take a very simple example. In our body, different brain parts are assigned different roles. The right side of the brain is assigned the logical things, and the left side is assigned the analytical things. So if something goes wrong in the brain by say somebody is hitting the head or you fall down somewhere, some part of the brain may become inactive. Immediately by parallel processing, another part of the brain will take over the control of those organs which are controlled by this. It's a natural process which happens in our body, not only in our body, it happens in the body of every living organism because it's a nature's gift. When some brain cells are damaged, those functions will be taken over by, and that too by parallel processing, not by serial processing. That parallel processing in computer is a difficult area where when the ANN studies are now going on in that line. But nature has got the system. So we should design the system such that the system will have the capacity to adjust itself when. So that means the system will be very compact. You don't have to give redundancy in the system. Redundancy in the system means suppose the bike is falling down. You don't have to give the bike another two wheels on the opposite side. Instead, you will just give a crossbar. This is an example for this principle 5. Those who would have ridden a bike, motorcycle will be knowing. In front of the rider, there will be a horizontal bar which is called the crossbar. And this crossbar is to save the person if the bike falls down. Otherwise, the bike will be on top of the person. To prevent that. So a simple crossbar is such a mechanism, very cost-effective mechanism, which can prevent a fatal accident. Okay, so an example for that. An example for the Le-Chatelier principle where the system will adjust to it immediately. Now come to the next. This I have given a mathematical expression for that principle. You can leave it. It's not that relevant. This also you can just leave. Now coming to principle 6. The embedded entropy and complexity must be viewed as an investment when making design on recycle, reuse, or beneficiary. What do you mean by entropy? I think people know what is enthalpy, what is entropy. Entropy is the heat or energy produced when a process is going on. I'll tell you an example. Say when the boiler steam is input into a thermal power plant, the steam will run the turbine, and after running the turbine, a partly cooled steam will escape. It's a waste material. So we will have a system in the thermal power plant such that even this escaping steam, which is an entropy, also will be used for further heating the water. It will heat up to a level, and that heated water will be next taken for further heating. So we are not letting out that the second stage after the first stage of utilization the turbine, the steam which is escaping may be around near 100 degree, but not exactly 100 degree because it will start cooling. The heat of that steam is reused for boiling partly. The water may not boil, but the water will heat up. That heated water can be further boiled. So this is a system by which we use principle 6. I think you understood. That system can be there everywhere. Take for example, when a bicycle you are designing, you are not pedaling the bicycle every time. The bicycle has got system such that if you pedal for some time, the gear system will relieve by itself and it can move by itself for some time. Only when you pedal, the gear will get connected. Those who know the bicycling will know. Only when you are pedaling, the gear will get engaged. When you are not pedaling, the gear will get disengaged. That is an example for this principle. So that suppose you pedal for 2 minutes, you can stop pedaling for 1 or 2 minutes. That advantage you will be having. See now the next principle. Of course, it's a continuation of that explanation. You can just skip this because I explained already what is that. Now come to principle 7. We should not design anything for immortality. There is no immortal thing in this world. Even the universe is mortal. Universal can end on a day. The universe itself can end. The solar system can end. Human beings will end. So there is nothing called immortal design. There is only livable design or sustainable design should be there. So there is no need to design a house for 100 years. Maker always used to tell, design a house only for 20 to 30 years. Why? Because your next generation will not like that house. They will build a new one. It is true. Civil engineers in this group, please keep in mind, never design a building for 100 years. Concrete, the average life of concrete is supposed to be around 65 years. But concrete buildings may survive 100 or 200 years. But you see, that becomes a concrete cemetery then. It's not going to be a livable house because your next generation, I have made so many houses, and I doubt whether my next generation will use any of these houses because they'll have their own concept. They want to have. I never stayed in the house made by my parents because I made houses in my own design. So the next generation will have their own design. So don't expect that the next generation is going by your taste and flavor. So don't make any design, whether it is an automobile, whether it is a house, whether it is a lathe, whether it is a small kitchen utility. Don't go by what our previous people used and what our next generation is going to use. For the next generation, leave it to them. You make so anything which you make. Of course, in Kerala, we use car for a long time. Of course, after 15 years, you need a re-registration, but still people keep it because they will have an attachment to that, they'll keep it. But in Western countries, especially in the US, the average life of a car is from only 2 to 3 years. They let it to the junkyard and the junkyard will just recycle it. And of course, there they make a car for 3 to 5 years. Whereas in countries like India, we make a car for 15, 20, 30 years like that. I know some of my friends using even I have got an old car with me, which is 16 years now. And of course, my family say don't sell it off because there are some sentiment to it. I don't know, whatever it is. But anyway, this can also happen. So like this, there is no point in having a longevity in design. Design for the required lifespan, whether it's a building or whether it is a machine. That is a better concept of sustainability. So that at the end of that period, you can recycle it, or you can remodel it, or you can reuse it. That is the concept. See the next. Okay, this you can skip because I told that. The previous slide you can just take. I'll take one sentence on that. Yes, this one. This is one where the life of the product exceeds our imagination. Plastics. Plastics do survive our civilization. These plastics we make from the crude oil, other than bioplastics we make from the crude oil. And many of the plastics have got lifespan hundreds of years, 100 years, 500 years, 5,000 years, like that. So though we use it only a day or a month, the plastic carry bag, how much time we use? Maximum 1 week or 1 month. After that, we throw it away. But it will remain in the environment for hundreds and hundreds of years. So it is better not to go for such products. That is why nowadays biodegradable plastics have come into picture. Biodegradable plastic, the simple technique. I think Dr. Radhakrishnan is in this group, who is a chemical engineer by profession. He knows the technology of bioplastics very well. Biodegradable plastics are nothing but, in the polymer chain, we introduce certain cellulose chain, so that the polymer chain, which normally do not break easily, if you include some cellulose chain into it, cellulose chain is nothing but carbohydrate chain. Introduce some carbohydrate chain into that, these polymer chains become breakable. That is the advantage. So it is better to go for biodegradable plastic. But even in biodegradable plastic, I am just cautioning you, the carry bag may decompose because it is biodegradable, but the plastic content in it will still remain for hundreds of years. Only the cellulose part will decompose, and it will become to invisible small pieces. But that pieces will remain here in the nature, on the land, in the water, and many of them we call now as microplastics, because it has been seen that the fish population in the seas, this microplastic content is growing very highly. This microplastic content will be there even if we use biodegradable plastic. We cannot prevent that. Otherwise, it should be fully biodegradable. That will be a weaker variety, but it is possible. And one of my students has found a new plastic which he makes from tapioca, fully biodegradable after some months. I don't know whether it is selling or not. Once he approached me with the project report, and then I studied it well, and I told him to go ahead with it. I don't know what is the current situation. A fully biodegradable plastic by tapioca. He wanted to establish, set it up at Bangalore. I'm not sure whether it materialized or not, because he has never come back to me again. I hope you would have made it. Okay. See the next slide. Principle 8. Design only for necessary capacity. That means if you want a house for only 2 people to live, why do you make a house for 10 people? If you want only a bicycle for one person to ride, why should you make that 4 people should be there or 2 people should be there? If you want a car for only 2 people to travel, why do you make a 5-seater? All these are extravaganza, uneconomical, inefficient. So hereafter, designs have to be such that you decide whom it is for. I came across one such situation some 1 year back. I wanted to buy a new car. I was thinking of buying an Innova car, because which is very safe, because I had a very severe accident in the car accident, and my both legs had to be reinforced. So I was thinking of buying a long car so that the middle seat I can occupy. Then I took its mileage. Its mileage is only around 8-9 kilometers, whereas many other cars do give a mileage of nearly 20 plus. So I finally didn't buy the Innova. I went for another car, of course, very good quality, but mileage is around 23-24. See, that is because I don't need a 7-seater or 8-seater car for me to travel. Only myself and driver will be enough. And sometimes I even drive myself. So why do we based on a 7-seater car and less mileage because of it? So this is one concept which comes in. And of course, the mileage of a car is very important when you go for long run. So this I feel is the concept we should have in every machine or even in house. And Keralites by nature are, I'm no exception. Keralites by nature are people who show off their house. Even if they want only a small two-room kitchen house, they make some 2,000, 3,000 square feet house to show that they are capable of doing it. I'm also sorry I did this in my early days, but if I'm doing it nowadays, I won't do it. It has happened. This happens everywhere. See the next slide. Okay, this you can skip. JS plant. This also. Come to principle 9. It is always advisable to go for multi-component products because these components can be used elsewhere. One simple example I'm saying, this is what really happened. Now, some 10, 20 years back, I was very active in the construction sector. I used to offer consultancy service in structural design and construction. At that time, one doctor at Manarkad came and met me. He's a well-known gynecologist. He said, I want to construct a new house. That is by the side of the river Tuda. Very good plot, a big plot, some 30 cents plot. He wanted to construct a house there. And why he came to meet me is there is an old house for sale somewhere near there. It's a very old house. And someone told me that that old house may be of some utility. So he asked me to come and visit that old house. So I went along with him. And I found that that's an old house around 3,000 plus square feet, constructed in laterite blocks, double-sized laterite block. That was the old system. Nowadays, laterite we have got single block. Olden days they used to have double block. I took one of that laterite block and tested in our engineering college laboratory, and I found that it is having almost the double the strength of the local laterite. The local laterite used to have only around 10 kilonewton per square meter strength, and this used to have almost double of that. That is one thing. Second thing, I found that the entire roof is made of teak wood and local country wood, mostly teak wood. And at that time when the house would have been constructed, teak was very rare. And then other than teak wood, the majority of the windows and doors are made of jackwood. Jackwood, very good colored. Matured jackwood they have used. And then the roof is completely tile, mangrove type tile. At that time, mangrove type tile was very common in this area. And I found that there is nothing in that house. And the construction of that old house is by lime mortar. Lime mortar means you can break away the pieces simply. No cement is used. So I told that doctor, you buy it. At that time, the owners of that old house were asking 1.5 lakhs rupees, because 1.5 lakhs rupees it was a good amount that time. It was a big house also. That was the only house they had. And of course, the doctor was asking me what to do. I said, I leave it to you, you bargain and get it. Since the doctor was very closely known to these people, he could buy that house for 50,000 rupees. And you see, all the tiles in that old house we use for making pillar slab in the new house. Pillar slab, the slab will be having tiles below. It's a Baker model construction, but the doctor didn't want the tiles to be exposed, so we finished the tile below. And after that, we sold half of the tiles to another vendor. See, only half the tiles were required. For the entire new house, the timber from this house was more than sufficient. And all the laterite blocks we cut into single pieces by cutting machine. And laterite blocks were excess after construction. So only some other materials like cement and reinforcing bar, etc., we had to buy for the new house. And in my estimate at that time, this 50,000 rupees which he spent for the old house would have benefited around 10 lakhs rupees for the new house. Because for the new house, we have to buy new materials, but this old material was better than the new material. So what I'm saying is this happened because that old house was having material diversity. Old house was having very good timber, very good laterite blocks, very good tiles. All this could be utilized. So it is always, nowadays, most of the houses we go with concrete. and cement mortar, which are never reusable. We can reuse it only for making aggregates. That too, not good quality aggregates. So that was one of the pleasure of having some old houses. It could be fully reutilized. So it was a totally sustainable construction. And wherever possible, nowadays, whenever somebody is going for some extension work, I advise them to go for steel materials instead of cement-based materials. Why? Steel, you can reuse it again and again whenever you want. Even after multiple uses, you can reuse it again. That's the advantage of, that is the beauty of using steel structures. Okay. See the next slide. Same way, many parts in an automobile, whenever we are selling automobile, when we want to buy a new automobile, the company will buy our old automobile at some replacement price. What they can do, they can only separate the parts and reuse something, and remaining they can just throw away to young material. So if there are reusable parts in the automobile, and if they are not subjected to wear and tear, this can be used for other automobiles equally well. That is one we can. It's raining outside after a long gap. I think you must be hearing that sound now. Okay. So this technology we can use for automobiles, we can use for houses, we can use for machine parts, we can use for even simple equipments. Everywhere it's possible, provided we have got one simple thing I'm saying, the automobile oil, the engine oil. Most of the workshops do collect this engine oil. They purify the carbon out of it and they reuse it for some other purpose, like for termite proofing, like oil coating, etc. And it is very good quality for that purpose. It should not be used in the automobile, that's all. An example I have just told. See the next slide. The next. Whenever you go for a design, we say there should be an appropriate technology in design. Appropriate technology in design means locally available materials, locally available technology should be used. And of course, nowadays we have got what is called standardization of parts, so that all the parts sustaining to the standards. I have discussed this in ISO and standardization chapter. Now we prepare or we make or we manufacture parts which conform to the standards, so that the standard components should be helpful as one component can be used in the other. That can save a lot of energy and materials also. You don't have to go and search for a new thing, because say all the headlights of the cars are the same way inside. Maybe outside will be different. Then you don't have to make umpteen number of designs. Many of the, of course, outer elements they don't make like that, because each car company would like to show that their look is slightly different. But most of the cars do have the electronics and mechanical parts inside very common. One example I am saying, air conditioners. Most of the air conditioners which you get in India are using the compressors made by 2 or 3 companies. Only 2 or 3 companies in India are making compressors for air conditioning. LG is making, I think. I don't know whether Samsung is making. But most of the other companies which are selling the air conditioners, they are not having their compressors. They are buying the compressor from some other reputed company and they are using it. That is possible because that interconnectivity and standardization is happening there. That can save a lot of material, because every company wants to make compressors. It will be very cost inclusive and very much wastage of material. So where there are some market leaders, they can produce at mass production, and the cost of production will be very less, and the material wastage can be reduced. Like combined kitchen, we go for combined kitchen, the waste in so many kitchens can be reduced, and there will be only one wastage, and that too can be minimized. That system. See the next slide. Whenever you design something, keep in mind that it has got something called afterlife. What you will do? After the life of something, what you will do? Either you will throw away, or you will repair, or you will reuse it, or you will redesign it. Whatever it is, when we design something, keep in mind this concept we are not having. Suppose you are making a house now. Just think what is to be done after its life is over. I told about the life, afterlife of a house which was dismantled, which was made 100 years back. But just imagine now you are making a house. After say 40 or 50 or 60 years, your next generation is going to dismantle it. What is going to happen to it? Have you thought of it? If you think about it, you will go to the concept of what is called green engineering. You will go for reusable material. You will go for reusable technology. Okay. See the next. Principle 12 is we have been discussing in different forms so far. Design should be based on renewable and readily available inputs. That is what I told, the appropriate technology. We should design something so that we have access to that raw material, so that the cost is very minimum. One simple example I'm saying, we are having a lot of coconut timber in Kerala. There is very good technology available in Kerala for processing this coconut timber and using it. But we go for imported teak from Burma. Most of the timber sold in Kerala is imported because we don't have that much timber in Kerala right now. And that is not a green technology. Maybe one day this has happened with the river sand. Kerala was having splendid river sand. Now nowhere in Kerala river sand is available. Now river sand is coming very rarely from Tamil Nadu. After a bit of years, that also will stop. So we have to foresee that this river sand is not going to be there. That has to be accounted even in the design principles which we have right now. See the next slide. All our 12 principles are over with this. Coming to the next slide. We are summarizing. We are summarizing. Let us see that. Previous slide. Summary I'm just saying. Your design should be based on certain principles. What are those principles? It should be inherent. Inherent means suiting the locality, suiting the situation based on tradition. It should be innovative. It should have new ideas integrated to that. It should be integrated. That means instead of going by the horse with the genie aspect, you should have a vision which is spread, 360-degree vision. So that any good thing which comes from anywhere, we should be able to integrate. And it should be interdisciplinary because, as I told, green engineering is not confined to any one system. You must be knowing that earlier, the fan which we use at home, were not having an aerodynamic leaf shape. So the fan leaf used to be very high. But now all the fans are having the aerodynamic shape. So the leaf size has come down. And even one session we discussed about the shape of the blades of even windmills, huge windmills, but the blade is around 15 meters long. They are having aerodynamic shape. So that so a concept, it is an innovation actually. And it integrates the principles also. Okay, so these are some of the concepts which we can have in engineering so that whatever we make, whatever we conceive, whatever we produce are friendly with the nature, accommodate the nature, and do not destroy the nature. And that is what is required from green engineering. Engineers do make things, who design things, who manufacture things without hurting the nature, with modern principles, rooted on the tradition, utilizing the local materials, then we call that engineering as green engineering, and that is the goal of sustainability. So with that, this session is over. Now you can have some 2 minutes break or 3 minutes break. We are having, and in that break time, I want you to just put the any discussion session on this because we were not having that discussion so far. And after 2 3 minutes, we'll start with the last session, which will take around 35 to 40 minutes. Any question anybody wants to ask? It's a question time. 2 3 minutes. I just want to give break to my thought and to your brain. Ask the questions whatever you want. Any concern question? I'm seeing the chat box. No one has got any question to ask? In that case, Bindu, please project the next slide. Now, you didn't ask any random question. I have got a question right now. Urbanization means moving on to cities. Urbanized cities or towns. That is urbanization. I've got. I have discussed with that the scope of Kerala. Kerala doesn't have urban area or village area designed as such. We told Kerala is a megalopolis. All the areas in Kerala are just like an advanced city. But right now in the Indian population, how much percentage is living in urban areas, cities or towns or metros? How much percentage of the Indian population is living in urban area right now? Anybody? Just put on the chat box how much you expect. How much population of the Indians are living in the urban area? Or what is the urban population percentage in India? No one has any answer? Ashwin Raj has put 41, Aparna Satyanath 25%, Shailesh Kumar 28%, Veena Sajikumar 40%, Bindumal VG 30%, Savida Stanley 50%, Ajmal Farhan 34%, Krishnendu 50%, Vyasa Narayanan 31%, Ashkar 45%, Rohit Bibin 30 to 40%, Rajisha K 35%, Abin KS 45.6%. 48.6%. Now, let us see what is the reality. When India got independence in 1947, more than 80% of the Indians were living in villages. But in the latest report I have seen, almost 49% are staying in urban areas. See, so many have given 50 or 48.6, like that, very close to it. 49% is approximate, not exact. Of course, any demographic calculations are approximately. We cannot prove it as such. So that is the present position. Okay. Now, another question which I am going to ask is, Yesterday, one country has decided that by the year 2030, their urban transport will be fully electrical vehicle. Yesterday, one country has decided that by 2030, that is 10 years from hence, their urban transport vehicles will be fully electric vehicles. Which is that country? Anybody? Yes, Ramesh Krishna has told it rightly. Uh, Britain, yes, you would have seen it came in TV. Why? Because the urban population is increasing and the urban workers are increasing. So Britain has decided that by the year 2030, almost all urban workers, otherwise they'll give a small percentage allowance, but that is yet to go. I think that percentage allowance they are yet to decide. Now another question is, which is the Indian city which made which has banned diesel and petrol workers? Which is the Indian city which has banned diesel and petrol workers registering in that city? Gautam has given. Okay, Delhi. But truly speaking, even though it is banned there, whenever I go to Delhi, I see that so many diesel and petrol vehicles are moving on the roads because they are registered in nearby places like Noida, Gurgaon, etc., which are in UP, at the boundary of Delhi. You can go and register there. A vehicle registered in Noida can run in Delhi because it's a adjoining district only. That is happening. But Delhi has banned registration of petrol and diesel vehicles in Delhi. Only gas run vehicles, that too, either the cracked gas available there or the natural gas available there, they have to use for. Anyway, not LPG. LPG is for cooking purpose. They have to use either LNG or fuel cracked gas is also available there. LNG is the most commonly used natural gas, liquefied natural gas. Okay, now let us see. This I took as a small break because you are hearing for a long time now. Now that we can go to what is urban development. So you have got some idea by these questions I asked. What is the menace of the urban transportation and the urbanization? What is the objective of sustainable urban development? The objective of sustainable means that can last for long lasting or long surviving. That is sustainable. I told in the beginning of the sessions, I told you sustainable in Malayalam we say susthiram, that can last for a long period. So sustainable urban development objectives are to understand and appreciate the components and goals of sustainable urban development or city development. When people are growing, the number of people are growing, population is bursting, we should be able to contain them. You know that some 2-3 years back, a footbridge in Dadar has collapsed by the weight of people over it. The footbridge was full of people. It couldn't contain all those people. It collapsed. It was an old bridge. That can happen anywhere. So we are amassing in numbers, and that may affect. Once I have mentioned in the class that the entire problem of environment is caused by the multiplicity of the population, by the geometric growth of the population. That is a problem right now. Now see the next slide. When we go for urban development, we always have some concept in mind. First concept is that development should be consistent with national goals and priorities. So that, of course, we have got limited land, we have got limited resources, so we cannot avoid going for vertical development. But vertical development should be such that it should not be unlimited. That is one thing. Second point is that the planning process must provide for sustainable development. Whenever you plan something, You should ensure that development is there, but it should be sustainable. Development is not for 1 week or 1 year or 1 decade. It should be long lasting. And the third concept is that sustainable urban development is not the sole domain of the town and country planners, but also the livelihood and the existence of the human beings are also there. So development alone is not. Sustainable development may include a growth of transport, growth of construction. All this may be there in a sustainable way, but also we have to see that the people have to survive. Take, for example, the city of Mumbai. It is one of the most populated city in India. One of the most populated, one among the most populated 10 cities in the world. And Mumbai is such a city where there are more than 30 lakhs care lights available. And that city have the biggest slums in the world. If you want all of a day to remove all the slums, these slums are intertwined with the development of the city, with the existence of the city, and we should also see to it that along with the sustainable development, the people can also survive. These are all the basic assumptions required in sustainable city development. So all of a sudden, somebody was asking me long back, why couldn't you remove the entire slum of the city of Mumbai overnight, like what Sanjay Gandhi did in Delhi? It's not possible because in most of the houses in Mumbai, the house workers, the cook, the ironing hands, the dabbawala, and all such menial services, people are coming from this crowded slums and all. So you cannot prevent all of a sudden the slums because the slum is a part of the nervous system of the city. Cutting down, it will bleed. That is there. See the next slide. These are the goals which we have discussed in the initial stages. First three goals of sustainability we know, environmental, economic, and social. But when it comes to urban development, there is one more goal which has to be attached to it, institutional dimensions, because most of the development conglomerates, the office complexes, the transportation networks, all are linked to the urban system. So in addition to the basic goals of sustainability, the urbanization has got one more goal, which is the institutional dimension, which we cannot neglect. You can say that the city Thiruvananthapuram should be highly sustainable. There should be everywhere green plants and green paddy fields, etc. Is it possible? Thiruvananthapuram is full of government offices. How can it be greener than that? Very difficult. But within that ambit, how it can be made greener? You go to Secretariat, you see many of the buildings behind the Secretariat are very green, and even the front yard of the Secretariat is very green. So that is a compromise which we make amidst the developmental needs. So that is what is called institutional dimension. We cannot neglect it. All other dimensions are important, but this dimension gets intertwined in what is called urban development. That is why in every urban cities, of course, Tiruvandhuram, there is one area between uh, Vellayambalam to Kavadiyar Palace. That is called the hereditary site at Tiruvandhuram. On both the sides of that road, you are not supposed to construct anything new without the permission of the town planner. But even then, people do it. But it is supposed to be a traditional conserved area. It's a conservation area where you are not supposed to change the facet or the facade of the construction. Such areas are there in many of the cities across the world, in hundreds of cities. If you want to construct something, or if you want to affect the facade of the city, you cannot do it without the approval of the concerned government agency. Concerned government agency may be the archaeological agency or maybe the planning agency, it depends on it. See the next slide. Then there are so many environmental aspects which you have to take care of when you go for urban development. Urbanization also has got the same environmental aspect, which I'm not discussing here right now because all these environmental aspects we have discussed for other places. They are equally applicable to urban, like reducing the energy use, reducing the water use, minimizing the area of use. All these are common anywhere, not only to urban areas, but that those environmental aspects are there for urban areas also. Now see the next one. Now the economic dimensions are more for the urban area. Compared to the village area, compared to the non-urban area or compared to the mofussil areas, the urban area is very vital because there was a time when the economy of the country was managed by the peasants, the farmers. 80% of the economy of the country used to be dependent on the farmers. The farmers used to be dependent on the rain, on the nature, the climate. But now things have changed. Now only 20% of the economy of the country is dependent on farmers. That is why the peasants have become an insignificant part of the national economy. That is why they are not being considered by the governments also, though they feed 100% of the population. But in addition to that, there are so many economic dimensions. Economic dimensions in the sense most of the infrastructure development is in the urban area. The village area very rarely. Most of the land cost, village area, the cost of the land is very less, but urban area it is very high. Most of the financial institutions and financial markets are in the urban area. Then most of the educated workforce are in the urban area. In the village, we have got mostly Kerala. I told is an exception. Kerala, even the village workers are educated, but in most of the other places in the world, the village workers are uneducated. Even in the highly GDP country like China, the education level is very poor. Most of the villagers in China are uneducated. We may feel that China is richer than India, but the villagers are still uneducated. So all these are some of the economic dimensions. Now see the next dimension, the social dimension. What are the social dimensions of urban area? First social dimension is that urban area contains, that is not given in this list, but urban area contains very highly influential people. That is why you see that if power cut is there in a village area, sometimes it may last for a day or two. But power cut in some urban area, it will last only for minutes or maximum hours because some influential person will be immediately involved in it. So it has got social dimensions. Similarly, the crime rate is very high in urban area. Why? Urban area, nobody is concerned about nobody else. People have got their own dens and they are concerned about their personal matters more than the other people. In village area, it's not like that. Everybody is concerned about the neighbor. Everybody is concerned about the village. Everybody is concerned about the livelihood. These things are not there in urban area. Urban area, we have got what is called a pseudo-independent situation. Everybody pretends that they are independent, but actually they are not. They are all intertwined in livelihood activities. And moreover, in urban area, the rich to poor difference is very high. In take a very simple case of the Mumbai metropolis. I've been there in Mumbai for 2-3 years. I have seen the life of Mumbai. Even at that time, I lived there more than 3 decades back. Even at that time, there were very rich people in Mumbai earning monthly salary of nearly 1 crore of rupees at that time. But even at that time, there were people in Mumbai earning only 20 rupees a day or 10 rupees a day. See the difference or the ratio between their income. So that ratio is very high in Mumbai, but that cannot be very high in a village. Say, in a village area, say Patambi, for example, the difference in income of the richest man and the poorest man will be much less than that ratio in a grown metropolis like Mumbai or Tokyo or somewhere like that. So that is why uh, the social spectrum of an urbanized area is much different from a village area, a non-urbanized area. And that is why when COVID came, almost all the urban poor returned to their village area because in village area somebody will help them. Whereas in urban area, no such concept is there. If you are rich, you take care of you. If you are poor, there is no one else to take care of you. Whereas in village, your neighbor will take care of you even if their limit is very less. So that social dimension is there. So these are all some of the threats to urbanization and some of the threats of urbanization as well as some of the ground realities of urbanization. But in addition to that, urbanization makes necessary a lot of infrastructure like transport facilities, like meeting facilities, even in places like Delhi and in places like New York or Washington DC, there are separate earmarked places for strike. People who go on strike will have to go and sit there. In Kerala, we have strike everywhere. And of course, somebody who has visited Kerala long back was telling that this is a peculiar land where they see that any place is used as a toilet and any place is used as a land for resistance and strike. That is a peculiarity of Kerala, maybe a special model for Kerala alone. But anyway, I'm just quoting that this can happen in urbanization. The social dimensions also can be there. So our infrastructure development in urbanization has to be accordingly based for mass housing, based for mass transport, based on mass drinking water facility, based on mass pure air facility. All these things have to be there. Okay, see the next slide.
Sir, also,
So the institutional dimensions which we have in urban area will have all these matters embedded in it. Political dimensions will be there, then administrative dimensions will be there, then sustainable concepts should be there, legal frameworks have to be there, then stakeholders involvement. Take one example. If you want to clear all the slums in Mumbai, it's not possible without involving those people. I just take one case of Tiruvandhuram. Why should we go to Mumbai? In Tiruvandhuram, behind the secretariat, there was a slum area. I forgot the name of that slum area. I just forgot the name. It's a very notorious area by name. All the slum dwellers were told that you'll be given houses. You'll be given, framed buildings with houses, 1 or 2 bedrooms and all. You'll be given, and they were all given that houses also. But later, an NGO visited these houses and conducted a survey. They found that all these houses were being inhabited by rented people. The original slum dwellers never went there. They rented it out to new people who took this on rent. And when the reason was inquired by the NGOs, it was found that these slum dwellers preferred the environment and the living styles of the slums, not of this, RCC buildings. So this can happen. So even if the government wants to give them every infrastructure, sometimes they may not prefer. The people who, yes, that colony is called Karimadam colony behind the secretariat. The Karimadam colony, it has happened like that. Similarly, suppose you want to relocate all the slum dwellers in Mumbai, you offer them very good houses. They may not sometimes occupy it because they feel that their lifestyle in that slum area is better for them and which one they can digest, because it is just like taking the Adivasis out of Attapadi and offering them flats in town. It can happen like this. So, so many social issues are also involved in this, and all this have to be taken care of by the institutional aspects, and relevant and effective regulations only will solve the issue. Relevant and effective means first you have to study. Otherwise, it will be like Tughlakian reforms. That has happened in many places. Tughlakian. I see this in Karimadam colony also. The same thing has happened. So our reforms for urbanization should not be based on our belief system. It should be based on the belief system of the dwellers. Teachers many times have a feeling that what they do are right based on what was their perception when they were students. But if they want to know what is the present day perception of the student, they should better ask the students, which we very rarely do. So the best judge to comment on how is a class or how is a teacher is the present student, not his or her peer group or not our own conscience. It is the students who can better comment on us. Okay, see the next slide. Then, yes, come to transportation and urban sustainability. We need transportation facilities. See, any urban network is dependent on transportation. When the COVID has, worked, many of the households in Delhi and Mumbai came to a standstill because the workers used to come from 4 or 5 kilometers away, either by local metro train or by buses or by such public transit. Now it is difficult. I have myself heard a relative telling that now they don't have workers at to attend their needs because they cannot come by the local transport. Public transport is not available. Definitely, the workers cannot afford to have individual transport also. So, transportation, the urban network is a facilitation for the urban existence. Without that transportation facility, the urban network will not stay for there. See the next slide. So every city requires a vast supporting system. One simple example, the only town in Kerala where a sewerage system is there, that is Thiruvananthapuram. I don't know how many of you are aware of it. In Thiruvananthapuram city, the old city part, including East Fort, West Fort area, there's a sewerage system where all the toilets are interconnected by sewer pipes and they are taken to the sewerage treatment plant near to the sea coast, very close to Sengapore. So it is being taken in kilometers length by sewer pipes. So somewhere some blocks do develop, the entire city will be affected. Of course, in Kerala, nowhere else the sewerage system is there. Everywhere you have got isolated system. In Bombay, for example, there's a sewerage system. The old city of Dadar, Sion, all these areas connected by sewerage system, and they are taking to the treatment yard. Dadar, there's a big treatment area. They are taking to there. So if a sewer gets blocked, the entire city will get affected. So we have to have some system by which all this can be taken care of. Similarly, transport system. In Delhi, most of the transport is dependent on bus. In Mumbai, most of the transport is dependent on train, local trains. In Thiruvananthapuram, most of the transport is dependent on city buses. And what will happen when the city buses system is blocked? That has happened now. Now the transport within the city, the urban network is so weak. And what has happened as an effect of that is the individual vehicle system has grown up like anything, private vehicles. Before this COVID, we used to have nearly 1.3 crores vehicles in Kerala. I'm told that now it has risen to 1.6 crores. Two-wheelers and four-wheelers both have increased in numbers. Of course, the vehicle cost also has increased nowadays. And of course, the urban roads, when the public transport system is not there, the road load is a bit less. The urban transport load is a bit less. And hereafter, I feel that the private network is going to flourish because people feel it is safer, though it is a bit costly. So instead of getting into a public bus, now those who are having a two-wheeler would prefer to travel by the two-wheeler, though the cost is bit high. This is happening. So, but these things may change. The urban system will come back to the normalcy, and at that time, the public traveling system or transport system has to be good enough so that it can accommodate for that. And all the infrastructure, like the buildings, the transport, the water supply, the electricity. Last month for a day, the electric supply at Mumbai was at a standstill. What was the reason? Mumbai, majority of the area electric supply comes from BSES, Bombay Suburban Electric Supply, BSES. That is owned by Tata. Somewhere in one transformer, some hitch developed. The entire Mumbai was without electric connection for a day. Unbearable for a city like Mumbai because everything is in most of the people cook with electrical appliances there because they have got makeshift arrangement where gas or such things may not be easily available. So the city came to a standstill when BSES had a broken system for a day. This can happen. So urbanization has got a lot of challenges like this, and transport, electricity, water supply, all these services to the urban system have got complexities involved in it. See the next one. So all the public works and public utility. And one more thing is the land area available in the urban area is quite less. So the population per square meter or per square kilometer is very high in the cities compared to the city of Mumbai is having now nearly 2 crores population, more than half of the population of Kerala. It's very high. But what about the area? Very small area. So you cannot walk without touching one another. Most of the railway stations, you just stand in a queue and you are pushed to the train or pushed out of the train by the people behind you. You don't have to do anything. Only thing is, if you have some mobility problem, people will walk over you. That is the difficulty. So urbanization has got this difficulty in its infrastructure development. Maybe in future, some solutions may come, and the best technology or best methodology to be adopted in future is reduce the travel time for job. I don't know when it can happen. Take for example, a person who has to travel 25 kilometers to reach a job. In Bangalore, it may take 2 plus 2, 4 hours to travel. In Mumbai, it may take 1 plus 1 hour to travel. And even in a town like Palakkad, it may take 45 minutes plus 45 minutes. So if person is staying close to the workplace, or if the person is having online work, that will be the better system for the future. But I don't know whether online system can be there in production industry or some only in service industry we can go for. And teaching is a service industry. Only in service industry we can go for online systems. In production industry, definitely we have to go for the offline system. So the city has to accommodate all these things. Please see the next slide. So whenever the city development is happening, all the parameters which I discussed earlier, as well as what is the carbon footprint which the city is going to make. The carbon footprint of every city is very important because you know that the carbon footprint depends on how much is the carbon emanated from that area by all the human activities. Other than the nature's activities are always there. But whatever the human activities give rise to carbon output from there, that is what is the carbon footprint in excess of what is there. Okay. So whatever is the minimum carbon footprint for a system, we have to adapt to that. And then another thing is the land is a very restricted resource. Land is one resource which neither can be increased nor can be decreased. There are two resources with you which you cannot do anything, it is fixed. One is the land and one is the time. These two are resources which man cannot do anything, but time has got a peculiar.
Sir, voice കട്ടായി പോയി
You cannot
കേൾക്കുന്നില്ല.
hear now? Can you hear now? Can you hear now?
Yes, sir, you're audible. Yes.
Okay. So land is one thing which cannot increase or decrease, but the possession can change. But time is something, even the possession cannot change. Your time, nobody else can rob. There are only two things in this world which nobody can rob. That is your knowledge and your time. And those are your strengths. So we used to say in motivational sessions, the strength of an individual is the knowledge of the individual and the effective utilization of the time of the individual. So we say some people are great if they can use these two things effectively, their knowledge and their time. We say some people are failure in life if they don't know how to use their knowledge and their time very effectively. And obviously, there are huge differences observed in the land use in cities and villages. The land is very costly. Say an idle land is there in the city. Even if you are not cultivating anything or you are constructing anything, you can make money out of it. An example I got in Mumbai. In Mumbai, there were some landlords earlier, and even now this is happening in suburbs of Delhi, like Noida and like Faridabad area, where there are some landlords. They have enough land with them, traditionally acquired by them. They don't want to do anything, so they just lease it out to builders and real estate dealers with a huge amount of lease. Huge amount of lease means 1 acre of land you can lease at crores of rupees in such places like Mumbai or Faridabad, and you just get that income. And the builder or real estate developer will construct something and rent it out and make that income out of it. This is happening there. So these owners of real estate, owners of the original owners of the land, get a huge income without doing any work, just by means of their possession of their land. So land use is very costly in urban areas, whereas in village areas you cannot think of this. So urbanization, this is one of the wise which inviting it. The land will be utilized more. Land will be more, unnecessarily used also because it will be congested in the future like that. See the next slide. And sustainable transportation means basically some 4 things I am discussing in this. What is unsustainable transportation? If you avoid that, that is sustainable transportation. Second thing is, what are the general indicators of sustainable transportation, like mass transfer, etc. Then the third one is, what are the unsustainable impacts of cars, not like cars, any private vehicle for that matter. Then fourth thing we are going to discuss is, this is going to be our last discussion. Fourth thing is, what should be there for sustainable transportation and land use systems in the city. See the next slide. In unsustainable transportation, you use large inputs, use large infrastructure, you use large number of workers, you use a large quantum of fossil fuels like petrol or diesel, and you make a lot of waste. Depends on gasoline. Gasoline means the fuels like petrol, diesel, all these things are called gasoline. They are made from crude oil. And pollution is very heavy. These are all unsustainable transportation. So if you can avoid all those things, we say it is sustainable transportation. With less pollution, with less investments. So the most sustainable transportation is walking by our own foot. Next to it is using animals like horse or bullocks or something like that. And the third is some biofuels which we get from the nature itself. See the next slide. So these are the outcomes of unsustainable transportation. Production of CFCs, noise, land consumption, congestion, accidents. These are all happening when this transportation is not sustainable. See the next. Then what are the general indicators of sustainability in cities? There are so many indicators, and all these indicators, one thing is there, the quality of life of people should be better. Then the travel time required by people should be less. And then the automobile dependence should be less. Then we can say the general indicators of life in a city are better. I quote one example. Some 40 years back, when I was very young, I had a habit of going to Bangalore and staying there for 2-3 days, all alone, just to enjoy the city. At that time, Bangalore was a very pleasant city. Transport was very low. You can walk anywhere in the city, and all was green, and the climate was quite comfortable, moderately cool. But now, if you go, it is one of the worst cities in India. 3-4 years back, I went there for a conference from Bangalore city center to St. John's Hospital, around less than 20 kilometers, 17 kilometers. It took 2 hours for me to travel by a hired transport. See, so is it a good urbanization? I don't accept. Moreover, the entire street was full of dust and dirt and smoke. So Bangalore has become from a sustainable city to a non-sustainable city. But I have seen a reverse change in Hyderabad. I think in 1984, I stayed there for 2 weeks for an FDP conducted by IST. At that time, I was living in the heart of the city, Dekadikapur, and the city was quite congested and quite smoky, etc. But later, after 25 years, I went there and I found that the city is very clean and very attractive. At that time, Chandrababu Naidu was ruling that country, that state. But last year, I went again there because now my son is there. I frequently visit there. When I went there, I saw that the city has gone back to its past, again the dirty city. So a will of some individuals can make a city clean, and the mischief or misery of some other people can make a city worst. That is the case of Hyderabad, which I have seen in the last 4 decades. So things like this will happen to cities also. Rulers. Tiruvandhuram was once the most beautiful city in the country. Especially in the pre-independence area. People used to quote that. Tiruvandhuram was one of the most beautiful cities. But now what is the condition? You can comment on it. I'm not commenting. So indicators are there for the cities. Now, recently I have been to Chandigarh for a NAC inspection. I have been in Chandigarh. I found that Chandigarh is still keeping its beauty. Maybe it is because of the architect Lake Corbusier. He kept apart all the industrial part and all the business part away from the domestic sides. Maybe that planning of architect Le Corbusier is still keeping Chandigarh in a good way. I just enjoyed walking in the streets in the domicile area of Chandigarh. Very few cities are now like that. Okay. Now see the next slide. Of course, this I have also mentioned that the worker population in a city is never going to improve the population. Except the worker population or the public transport, like Singapore, public transport is the common thing, and private vehicle is very costly. So they can't keep their city. In countries like Switzerland, they don't even give private vehicles to even ministers. When the minister in the country has to adapt to public vehicles. Otherwise, if they use private vehicle, they have to spend themselves. So such measures can make the cities beautiful. But I don't know how when we will go. We are growing to a level of bitterness, not betterness. That is what is happening in India. So cities are growing to be menaces. I have not seen any city in India growing more beautiful. I've mostly seen cities growing more worse and worse. So because the indicators you point at it. See the next slide. And obviously the private vehicles. I have no right to comment on this because I'm using a lot of private cars, but in the long run. But I also see to it that my vehicle is running the minimum. That is the only way we can do, because we are so much dependent now on private transportation. Otherwise, it is very difficult to afford it, afford our even workplace. But when the public transport system improves, so what I have found a way now. Personally, I have found that I stay close to my office most of the days. So only 1 or 2 days in a week I go to my home. Remaining days I'll be in the official quarters so that I can save the fuel. That is my point. And obviously, whatever less it can, whatever it can contribute to lessening the burden on the environment, it will be that much, but a small contribution. But many people cannot do it. They are forced to resort to private vehicles. And I have seen the most prominent environmentalist in Kerala always traveling by an air-conditioned car. And I sarcastically asked her how it is happening. She said she is physically not well, so she needs it. But her environmentalism and her physical needs are entirely different. So this can happen. Okay, see the next slide now. So the private vehicles, cars means it's not the small four-wheeler which we are using. Car in generalism, the name given for the private motor vehicles used everywhere. It can give rise to all these things which we have discussed in air pollution. It's causing all these difficulties. And of course, from the social aspect, it causes a lot of inequality also. Inequality in the sense, in many of the houses now in Kerala, at least 1 or 2 cars are there. And I still remember when I was working in a college at Tirunelveli, the peon in my office came with a request for a vehicle loan. And he was a low-paid peon, not very experienced. So I asked him, why do you want the loan? Then he told, sir, I want to buy a car. Then he asked him, why do you want a car? You're coming by bicycle. He said, everybody near to my house is having a car. So if I don't have a car in my porch, people will underrate me. So I'll buy a second-hand car and keep in my porch. I'll come every day on bicycle. See the mindset? And he took the car loan and purchased the car. One day he brought to college also. So I was seeing what is the mindset of the people here. So this happens. So these are all unsustainable deals which people do. Okay, see the next slide. So sustainable transportation should do justice to environment, economy, and society. Environment, economy, and society we have discussed great in detail earlier, so I'm not going to explain it. So any sustainable transportation should do justice to these three aspects: reduce the environmental impact, avoid the impact on economy, and do better to the society by safety, health, least disturbance, etc., etc. See the next slide. So with this, we are coming to the close. This is exactly 5 o'clock now. We are coming to the close of the discussion, and being the last session, if anybody wants to comment anything orally or by chatting, you are most welcome. I can wait here for 2 or 5 minutes more. Nothing wrong. If anybody wants to comment anything or anybody wants to, because you should not say that you didn't get a chance to talk at the end. Anybody? And for the students, I have arranged a session. We'll be meeting on 8th of December with my students in Ahalia. I'll be having a session later. But for the outside participants who are mostly teachers from colleges, and of course, I have got an information for you. I have formed a WhatsApp group of all the principals in Kerala, engineering college principals. Around 90 people have joined. Some more are to join. So all such information on academic matters I'll be passing on to them. They have all started interacting. So all these recordings I'll inform them, so that either you or the teachers who are taking classes there can share it to students. I want it to reach students. Teachers, you have got access, you have got better access to internet or your library or anything. There are hundreds of students in Kerala who don't have real access. So that is why I recorded all these sessions, so that recording they can just go through. And sustainable engineering is, I've not taught for the purpose of scoring mark. I've taught it for the purpose of social awareness and for the knowledge of the nature and ourselves. That was my purpose. And I like it from that point of view. I don't take it as a part of the compulsory syllabus. I feel that it is something which everybody should know from livelihood point of view, from existence point of view, and from nature's point of view. So if I have done some justice to that, that is what I feel good. I don't know how many of you have imbibed in that sense, and also I don't know whether I have done total justice to this subject. Basically, I told that I have come to environment because of the influence of my wife. She has a post graduation and doctorate in environmental engineering. So when our coexistence started, I also started developing some interest in environmental engineering. And thereafter, many of the state level, national level projects in environmental engineering I took up because we together could do it. So we as a team did most of the work. Maybe I had to learn a lot of environmental engineering because of getting involved in projects, and that's why always I'm interested in sustainable engineering. So if any of you have at any point of time you want to clarify something, whether my teachers in the colleges, whether my students, definitely you are most welcome. And of course, Bindu will ensure that whatever programs are here, you message to this group so that all of them, if they choose, they can attend it. So it is time for you. And if you have anybody else if you have anything else to talk to me, you can. And I'm a person always accessible by phone. My phone number is with you, but better call me after 9 p.m. only, because in the daytime it will be very difficult to take up the phone. Only for such sessions I reserve the time. But night after 9, or you can just message me or WhatsApp me. You'll get the reply, whatever help you want me to. And of course, I've been the Dean of the University of Calicut right from 2012 till last month. Now my tenure is over, and of course, still I'm involved in setting up so many institutions in our campus. So sometime we may have to meet, or we may have to discuss on academic aspects in future. As long as my health will permit, I'll be in academics. That is the only profession I want to be, and I will be. So thank you very much. If you have some questions there, nobody has asked any questions. Only thanks have come. Okay. One more minute, I'll wait. If there's no question, I'll just quit. And all the students, don't forget to join on 8th of December. Link will be sent to you because that is when we finalize the academic aspects. So to all the teachers who are present here, please convey my regards to your principals, because all your principals are in my WhatsApp group, I think. So please convey to all of them my regards, and thank you very much for being with me. Okay then. Thank you.
Thank you, sir.